let's explore the common pitfalls of the BGP network statement. The network statement is what advertises into the BGP process. And we might do something like this: network, and give it an IP address, and then a mask. The fundamental rule of the BGP network statement says it has to have an exact match. Now, if you were to AND this mask and apply that, if you were to AND the IP address and the mask, would you get the same thing? No. You would, in fact, the result of ANDing would be, let's see if I can find a good space to type here. The result is, this would be looking for really 192.168.1, which cannot exist. It cannot exist because in the routing table you would have .0. You would have .0. You can't have .1 in an octet which has a subnet mask value of 0. So it's an impossibility. So it finds nothing, and it needs to find the exact match. Another option at your disposal is to force the issue. Take a look at this. Network 192.168.0.0. Now, what class of address is this? That's a class C address. And so you would expect a 24-bit mask. And we're putting in a mask command or a mask argument that is a 16-bit mask. So it's not likely that we're going to own that route natively. But what we could do is this. We could say, I'm going to build that. I'm going to build that route for you. How would we build that route? Well, we could do something like this. We could build in something like this. We'd say IP route, move it to a better spot, 192.168.0.0. This is what it's saying in the text, but I want you to just really get a sense of that. So if you had that in your config, IP route 192.168.0.0, and pointing to null 0, then you would in fact own it and then advertise it. You would. Start to sound like Yoda there. Okay, so what is the route, or what is the null 0 interface? It means we're going to drop the traffic. It means we're going to send it to the garbage can. However, if you own more specific entries to member subnets within this space, you will use the longer matches inside of your routing table and continue to route to those networks. So in fact, this is a way to summarize routes. Think about route summarization for EIGRP and OSPF. We automatically get, with the IP summary address command in EIGRP or the area range command in OSPF, we automatically get routes to null 0. So all we're doing is we're manually doing the same thing. And this is in fact considered a good way to build in route summaries for BGP. One last challenge. The BGP network statement, when a mask is not used, will assume a classful mask. And it is the class of address that you have. So you get one of 3 masks. If you've put in a class A, where the first octet is 1 through 126, you'll get a /8. B, in prefix notation, get a /16, and C, 192, 223, you get a /24. So here, because it happens to be a class C, you get the 24-bit mask. You still have to be a perfect match. You have to be a perfect match. So, in this case, it's a little harder to read because you don't see it explicitly stated, the exact mask. But it would be read as if it said mask 255, 255. I'll put it in just so we understand. Mask. Mask. Boom. That would be how it would be read, okay? Understanding these little caveats, these little quirks to the BGP network statement will allow you to be more successful and get BGP running a lot quicker. These things will likely still affect you, but calling upon your recollection, your understanding of these, will probably allow you to solve issues when they do arise.